Alright, here in this problem, we're going to use both the Pythagorean theorem and the distance to figure out the distance between the 2 points. Now, we'll start out with the Pythagorean theorem. Now, to remember to do that, we're going to need to make a triangle, a right triangle, more specifically. And we'll stay at the same level for this one, okay, and we'll go over to the x value in this one. And then what we typically do is draw in the lines. So I'm going to draw the leg here and leg here to show that we're making a triangle. And then I'm going to draw in the hypotenuse, which this would be our hypotenuse. Alright, and so to use the Pythagorean theorem now, we're right on specific places. So what I'm going to do here is just count. So I'm going to say that I'm going to call this A. So I'm going to go 1, 2, 3. So A is 3, and then count. So I'm going to go, this line should be at 6, but 1, 2, 3, 4, 5, 6. So B is 6. So use the Pythagorean theorem. We're just going to use the A squared plus B squared is equal to C squared. So we'll have 3 squared plus 6 squared is equal to C squared. So we end up with 9 plus 36 is equal to C squared. Go ahead and add these. We get 45 is equal to C squared. Take the square root of both sides, and we end up with a square root of 45 is equal to C, which, if we do the calculator, is going to be like 6.7. Now I use that because we have to round for this part. Alright, now to use the distance formula, remember that D is equal to the square root of the change in X squared plus the change in Y squared. Alright, now with this, we're going to plug in the X and the Y value. So X squared, I'm going to do the change in X. I'm going to go -2 minus 4 squared plus 6 minus 9 squared. So we end up with, when I do this, I'm going to end up with -6 squared plus -3 squared. So we end up with a square root of 36 plus 9. Add those two together and we get the square root of 45, which is what we ended up with here, which is what we should have, which is approximately 6.7. So we can use the Pythagorean theorem to solve for it, or use the distance formula, which was derived from the Pythagorean theorem anyway, which we did earlier. Alright, now this one is not in your packet. It got left out for some reason. So you may have to do this on the back side of example 1. But let's go ahead and look at it. We're given a diagram here, but you really don't need that. We're going to determine that these two lines are parallel. Okay, so I'm just going to call, well, we're going to call this line 1, so I'm going to look for the slope of that one and the slope of this one. So the slopes have to be equal to be parallel. So the slope of this one and the slope of this one have to be the same. So what I'm going to do is find the slope of the first line. Now remember, slope is equal to y2 minus y1 over x2 minus x1. So it's the change in y over the change in x. Now with this, what we're going to have to do here though is, it doesn't really matter which one we call x1, y1 and all that kind of stuff, as long as we keep the same two together. So I'll just call that x1, that y1, x2, y2. So let's figure out those slopes. So I'm going to say 3 minus 5 over, okay, -5 minus -8. Now notice the 5 and the 8 go together, and then the 3 and the -5. The only thing that matters really is that you put those together. We could have had this all flipped. Just keep up with your signs and make sure. So what I mean by that is this: I could have had this. I could have had 5 over -8 minus 3 minus -5. Okay, and should end up with the same answer either way. Alright, but anyway, let's go. 3 minus 5 gives us -2 over -5 plus 8, which would give us 3. Now if I did this up here, I would end up with negative 3 and then 5. Now yes, the negative was associated with that one, but we only care if the whole thing is negative. So we end up with the same answer either way. Now for the second slope, okay, alright, so I'm going to call this x1, this y1, x2, y2. This is just mainly to help me keep organized when I start writing things out. So we'll go 1 minus 3. Okay, so it's the change in the y's, and then 4 minus 1. Well, I get 1 minus 3, which is going to give me negative 2. 4 minus 1, which gives me 3. Okay, these two things are equal, so these two lines are parallel because the slopes are the same.